The question is, amplitude modulators and demodulators can also be built without using multipliers. In figure 4.26, the input phi of t is equal to m of t, and the amplitude A is much greater than phi of t. The two diodes are identical with a resistance of R ohms in the conducting mode and infinite resistance in the cutoff mode, so that the output E naught of t is given by E naught of t is equal to 2R over R plus R, W of t times M of t, where W of t is the switching periodic signal shown in figure 2.20a with periodic 2 phi over WC seconds. A part is asking, hence show this circuit can be used as DSB-SC modulator. This is what we show in the last video. So this figure 2.20a, that is the square picture that is provided with the question, and here we proved in my last video I proved that we derive this equation E naught of t is equal to 2R over R plus R, M of t times W of t, and then finally we also prove that this can be used as a DSB-SC modulator. And here we are going to see how would you use the circuit as a synchronous demodulator for DSB-SC signals. So here we are going to see how to use this as a demodulator. Okay, now let's go ahead and begin. So here they mentioned that here we are going to have a phi of t, that is a m of t cos omega ct, and here also they mentioned that a is much greater than m of t. Okay, it's mentioned right here, phi of t is m of t, so since a is much greater than phi of t, that means a is much greater than m of t. And now here the phi of t is fed to the circuit, so now we are going to have E naught of t, that is 2R over R plus R times a m of t cos omega ct W of t. Okay, this is the equation we derived in the last question. If you look at this is the equation E naught of t 2R over R plus R m of t omega t, W of t. And here's the same thing, but only the difference is we are going to have a cos omega ct with that. Okay, and then now we have to put here we have W of t, that is basically the square signal provided to us in the question, that is this one, and the Fourier series of this one is represented by this. So let's go ahead and rewrite that one. So where W of t is periodic rectangular pulses, which can be expressed in Fourier series as W of t is equal to half plus 2 over phi cos omega naught t minus 1 over 3 cos omega naught t plus 1 over 5 cos omega naught t and so on. So this is going to be minus 1 over 7, then plus 1 over 9. So it's going to go forever like that. And then therefore we can say the output is E naught of t, that is given by 2r over r plus small r, a times 4 over 5 m of t cos omega ct, and instead of the w of t we put this function we have, the series, Fourier series function, that is cos omega ct minus 1 over 3 cos omega ct plus 1 over 5 okay, this one is cos 3 omega ct. Yeah, so this one should be like 1 over 3 mean cos 3 omega naught, then 1 over 5 cos 5 omega naught, so it's gonna go like that. This is cos 5 omega ct, and so on. It's gonna go forever. Now we're gonna go ahead and simplify this one. So here what we can do is this cos omega c and this cos omega c can be multiplied. So we will end up with 2r over r plus r, a times 4 over 5 m of t cos square omega ct minus 1 over 3 cos omega c times cos 3 omega ct, and then plus 1 over 5 cos omega c times cos 5 omega ct, this is bracket cos 5 omega ct, and so on. Okay, so it's going to go forever like that, and then we can simplify this one furthermore. So that is equal to 2r over r plus r, a times 4 over a m of t 1 plus cos omega ct divided by 2 minus 1 over 3 cos omega ct cos omega 3 ct cos 3 omega ct, and so on. Okay. And then simplify furthermore. 2r over r plus r, a times 4 over a 1 over 2 m of t plus cos omega ct divided by 2 m of t minus 1 over 3 cos omega ct cos 3 omega ct m of t, and so on. Okay, now what we are going to do is we are going to use a low pass filter and apply to that. By doing that, what we are going to do is we are going to remove all the cos parts. It removes all these waves, so this free cos parts will be gone. Now by passing E naught of t through a low pass filter, the output is E naught of t, that is equal to r 2r over r plus r times a times 4 over a times half m of t, and all the other part will be gone. And then we can simplify this one furthermore, that is a cancels, so this is going to be E naught of t, that is equal to 4r over r plus r and then m of t. Okay, so from this one we can conclude that hence the given circuit can be utilized as a demodulator. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.